This video is on solving one-step equations. An equation is a mathematical sentence that contains an equal sign. It means that the left side has exactly the same value as the right side. The two sides of the equation are equal to each other. So for example, 3 plus 5 equals 8 is an equation because 3 plus 5 is equal to 8. Both sides of the equal sign have the same value. Often an equation contains a variable such as x. To solve an equation means to find the value of the variable that makes the equation true. The value of the variable that makes both sides of the equal sign equal to each other. So for example, in the equation 3 plus x equals 8, x is equal to 5. Because when x equals 5, the equation 3 plus 5 equals 8 is true. To solve a one-step equation, we want to use inverse operations. That is, those operations that undo each other. For example, addition undoes subtraction, and subtraction undoes addition, so addition and subtraction are inverse operations. In the same way, multiplication and division are inverse operations because they undo each other. In solving equations, we use inverse operations to isolate the variable. That is, to get x all by itself on one side of the equal sign. This gives us the value of the variable that makes the equation true. We can check our solution by replacing that number for the variable in the original equation to see that it works. So let's try several examples here. We need to solve each equation, and then we're going to do a check of our solution. So my first one says x minus 12 equals negative 27. So what is happening to x? X is being subtracted by 12. So I want to undo subtracting 12 by adding 12, and I have to do that to both sides of the equal sign in order for the equation to stay equal on each side. So a negative 12 plus 12 is a 0. So they cancel each other out. They basically make a 0. So I'm left with an x on this side of the equal sign, and negative 27 plus 12 gives me a negative 15. Now to check my solution, I'm going to take that negative 15 and go back to my original equation and plug it in. So is negative 15 minus 12 equal to, notice I put a question mark over the top of the equal sign, negative 27. And indeed, negative 15 minus 12 is negative 27. So this equation checks. And my solution is x equals negative 15. In my next equation, I have negative 11/8 times x equals 77. Notice that x is being multiplied by negative 11/8, but I really don't want to divide by that fraction. Remember that you can dividing by a fraction is the same thing as multiplying by its reciprocal. So I'm going to multiply both sides of the equation by a negative 8 over 11. And what this gives me is a 1 over here because negative 8 divided by negative 8 is 1. 11 divided by 11 is 1. So I'm left with just an x here. And I can actually do a little canceling here. So I have 77 divided by 11. That becomes a 1. And that becomes a 7. So 7 times negative 8 is negative 56. So let's go ahead and check that and plug that back into our original equation. So negative 11 over 8 times negative 56. Actually, I think I'm going to write that as negative 56 over 1. That'll make it a little easier. Is that equal to 77? Okay, so again, I can do some canceling because 8 goes into 56 7 times. Leaves me with a negative 7. And negative 11 times negative 7 is 77. So 77 equals 77 checks. So my answer is x equals negative 56. And our last example here is 15x, and 15 times x is equal to negative 75. Notice that x is being multiplied by 15. So to undo that multiplication, I'm going to divide both sides by 15. 15 divided by 15 is 1. So x is equal to, and negative 75 divided by 15 is a negative 5. Let's do our check. is 15 times negative 5. Notice I put negative 5 back into my original equation for x. Is that equal to negative 75? And pull out my calculator and check. And indeed it is. So my solution in this case is x equals negative 5. So in this video we took a look at how to solve a one-step equation. We talked a little bit about what an equation is and how to use inverse operations to isolate the variable.